Hello everyone, my name is Timothy Mewa Joseph. You are welcome to Study Mathematics channel. On this channel, you are going to be learning a lot about mathematics. Different topics in mathematics will be treated on daily or weekly basis. So please subscribe to the channel for you to get notification of my lessons. So today we're going to start with laws of indices. Laws of indices. I need you to do this by yourself. So write in your exercise books, work out the following: 6 square or 6 raised to the power of 2, 4 cube or 4 raised to the power of 3, and 5 raised to the power of 4. We have root 49, root 121, and the third root of 64. Yes, or cube roots of 64. Remember that 6 raised to the power of 2 means 6 times 6. 4 raised to the power of 3 means 4 times 4 times 4 and times 4. And then root 49 means what number do you have to multiply by itself to get 49? Think about it. So you have a few minutes to do this. Okay, by now you should have finished. Let's check the answer. So 6 square means 36. 4 cube is 64. 5 to the power of 4 is 625, and root 49, of course, 7. Root 121 is 11. And then the last one, the cube root of 64 is just 4. So you can give yourself a mark out of 6 in your books. Be honest. Okay. Our learning objectives in this lesson are: 1, use vocabulary relating to index number. So you will learn how to use vocabulary relating to index numbers. Number 2, you will learn how you learn to know 2 special rules relating to index numbers. Know 2 special rules relating to index numbers, and then you will be able to simplify expressions by applying the first 3 laws of indices. So the keywords that you will be hearing in this lesson or in this video are power, index, or exponents. So sometimes I may choose to use power, or I use index or exponents. I am still saying the same thing, so don't be confused. So a power is a useful way of writing repeated multiplication. Just like what you are seeing on the screen, 7 raised to the power of 3, or we say that 7 cube means 7 times 7 times 7, that is 7 in 3 places. The same thing applicable to 9 raised to the power of 5, which means 9 in 5 places. 9 multiplied by 9, by 9, by 9, by 9, and by 9. And then we have a letter A here. So if it is a letter which is raised to a certain number, we do the same thing. So here we have A square, or A raised to the power of 2. So we say A times A. If you yourself as a human being, you are raised to the power of 2, like maybe you're twins. So which means you are multiplying yourself. Okay. So take a look at this number: 7 raised to the power of 3. The base here is the 7. And the power or index or exponent is 3, as you can see it here. And then the next is 9. 9 is our base here. It forms the base, and then the index is 5, just like what you can see. So this is the base, this is the base, and then this is the index or the power. And then we have A square. So A forms the base, and the 2 here is the power, the index. So the plural of index number is indices. So here we have 3 indices, 3 powers. 9 raised to the power of 5, 2a raised to the power of 2, so that is the index, and 7 raised to the power of 3, which is also the index. So the plural of index number is indices. Meet the indices police. Yes, this sounds quite funny. Yes, there are some rules or laws for combining expressions involving indices. What these indices police do is that they will arrest you if you break any rules and then put you behind the bar, right? So if you don't want to be arrested by these officers, you need to learn the laws of indices. I need to avoid making mistake while solving any problem. Laws of indices. What are these laws of indices? There are some rules for combining expressions involving indices. Special rule 1 says any number to the power of 1 is the same as the original number. Take a look at this. Any number to the power of 1 is the same as the original number. So here we've got 32 to the power of 1. It is the same thing as 32. Another 5 is raised to the power of 1. So 5 is the base and 1 is the index here. So it is the same thing as 5. What about 12 to the power of 1? So any number raised to the power of 1 is the same thing, be it whole number or decimal, just like what you have here. We have on the screen. 44 to the power of 1 is the same thing as 44. Yes. And then u to the power of 1, you are the same thing too. So what about letters? Yes, a to the power of 1 is the same thing as a. Y to the power of 1 is just the same thing as letter y. X to the power of 1, it is the same thing. Okay? So it is a raised to the power of 1 is a. 1 is to the power of 1 is 1, of course. Y raised to the power of 1, it's also y. So that is the special rule. See? Okay, I don't need to flog this too much. Let's move to the second rule. Any number to the power of 0 is equal to 1. Any number which is raised to the power of 0 is equal to 1. 6 raised to the power of 0 equal to 1. 35 raised to the power of 0 is equal to 1. Yes. 41 raised to the power of 0 is equal to 1. Yeah. And do we still have more? Okay. Minus 13 raised to the power of 0 is 1. What about letters? The same thing applicable to letters. Yes. So if you have a raised to the power of 0, it is the same thing as 1. X raised to the power of 0 is the same thing as 1. Yes. Y raised to the power of 0. Oh, sorry. So let me take away this guy. Y raised to the power of 0 is 1 equally. And then what about u? If you are raised to the power of 0, it is you are 1. 1 million raised to the power of 0 is 1. So I wouldn't allow anyone to raise my $1,000,000 to the power of 0. Yes, because I don't want to have 1. So we've got a lot, and then so anything raised to the power of 0 is just 1 in mathematics. So please take note of this. Okay, let's look at some of these laws of indices. Law number 1, which is multiplying numbers in index form. Example 1, simplify 8 raised to the power of 3 and times 8 raised to the power of 4. How do we do this? Watch. So since we have 8 raised to the power of 3, it means that we're going to express this 8 in 3 places. That is 8 times 8 times 8 and times 8. And then times 8 times 8 times 8 and times 8. Since we have 8 raised to the power of 4, just like this. Yes. So what do we have? How many 8 do we have? We've got 7 8. So we are going to write this as a single number, that is 8 raised to the power of 7. This only works for numbers with the same base. Please take notes. Example 2. Simplify 5 square times 5 to the power of 4. 5 raised to the power of 4. The same thing. So we have 5 square or 5 raised to the power of 2. So we are going to express this 5 in 2 places and 4 and 5, the second 5 in 4 places. That is 5 times 5. And then we say times 5 times 5 times 5 times 5. So how many 5 do we have here? We've got 6 5. So we are going to write it as a single number, 5 raised to the power of 6. This only works for numbers with the same base. So if you have 5 raised to the power of 2 times 3 raised to the power of anything or 4, you can do it like this. You can express it in this way. Okay. So is there a quicker way of doing this? So there should be, this is A, not what is there. This is A, sorry. I'm gonna change this to A. Yeah. Okay. Is there a quicker way of doing this? Of course there is. Take a look at it. Yes, the quicker way of doing this is add the powers. When you multiply powers with the same base number, you add the indices together. That is a raised to the power of x multiplied by a raised to the power of y is the same thing as a raised to the power of x plus y in brackets. You can see. So in this case, if you don't want to express the numbers to write many numbers or repeating the numbers, so you will just say this one, that is the power 3 plus 4, so it's going to be 7, and then here 2 you plus the powers since they have common base. So the index is 2 plus 4 we give 6. So this is the quicker way or the fastest way of doing this. Yes. Okay, I need to erase this. Okay, let's move to the next. Guy, why are you staring at me? I am not breaking any laws of indices, okay? So you need to smile. Stop staring at me and trying to scare me. Come on. It is your turn now to practice. Write as a single power of 5. So here you have 5 raised to the power of 3 and 5 raised to the power of 2. Remember that you are going to add the powers, as I have said. What did you get? Oh, so if your answer is 5 raised to the power of 5, good job, excellent. So you get it now. You are not going to be arrested by the steering officer. The next one, 5 raised to the power of 7 times 5 raised to the power of 4. So what do we have? It's so simple. Just add the power since they have common base. What do we have? Yes, 5 raised to the power of 11. That is 7 plus 4 gives 11. And then the next one, let's keep practicing. 5 raised to the power of 10 multiplied by 5 raised to the power of minus 4. So the same thing you had. So what do we have here? Okay, so if you got 5 raised to the power of 6, you are correct. Well done. And 5 raised to the power of 2 multiplied by 5 raised to the power of minus 8. What is going to be this answer? So if your answer is my 5 raised to the power of minus 6, good job. You are absolutely correct. And this, so we have 5 raised to the power of minus 9 times 5 raised to the power of minus 3. What do we have here? So if your answer is 5 raised to the power of minus 12, you are absolutely correct. Clap for yourself. Let's go to the second law, dividing numbers in index form. I don't know why these officers are just staring at me. Am I breaking any laws of indices? No. So you need to smile because I'm making you guys happy. So you're just looking for someone to arrest. You're not going to arrest me, neither my students. So keep calm. Okay, example 1. Simplify 2 raised to the power of 5 divided by 2 raised to the power of 2. So this is division law. We express this first. 2 times 2 times 2 times 2 times 2, that is 3 in 5 places, divided by 2 times 2. So what do we have? So 2 cancel 2's. So we should have 2 raised to the power of 3. Do I need to explain this better? So okay, so this 2 we cancel this 2, and this 2 we cancel this 2. Okay, where's my? I need to cancel it because this officer is just waiting for me to make mistakes. So this cancel this, and let's take this out, and then we have 1, 2, 3. So we have 2 raised to the power of 3 here. So remember again that this only works for numbers with the same base. Okay. Okay, let me get rid of this, and then we consider another example. So simplify 3 raised to the power of 6 divided by 3 raised to the power of 4. What do we have here? So you express 3 in 6 places, just like what you can see on the board, and then you divide it by 3 in 4 places, again like this. So this 3 we cancel this cancel this take out this, and this take out this. How many 3 do we have left? 1, 2. So 3 times 3, which means 3 square. 3 raised to the power of 2. Again, remember that this only works for numbers with the same base. I keep reminding you this because I don't want this officer to arrest you. Now, there is a quicker way of doing this again. So when it is multiplication with the same base, we say that we had the powers, but in the case of division, so what we do here, the fastest way is to subtract the powers, the indices. So 2 raised to the power of 5 divided by 2 raised to the power of 2, we have 2 raised to the power of 3. Why? Because we just subtract the powers. So 5 minus 2, and then the same thing applicable to this. So when you divide powers with the same base number, you subtract the indices. Yes. So in the summary, a raised to the power of x divided by a raised to the power of y is going to be a into brackets x raised to the power of x minus y. This is very simple to do. Then we move to the, okay, I think I've explained this, so we just need to practice now. So it is your turn. Write as a single power of 6, 6 raised to the power of 5 divided by 6 raised to the power of 2. What are you going to have? Okay, so if your answer is 6 raised to the power of 3, you are right. Good job. 6 raised to the power of 15 divided by 6 raised to the power of 5 as a single power of 6. So if you get 6 raised to the power of 10, you are absolutely correct. Well done. Okay. And here we have 6 raised to the power of 9 divided by 6 raised to the power of 10. Keep staring at me, this officer. We are not going to make any silly mistakes here. Okay. So 6 raised to the power of 9 divided by 6 raised to the power of 10. So if your answer is 6 raised to the power of minus 1, you are correct. Good job. And the last, 6 raised to the power of minus 4 divided by 6 raised to the power of 3. So we subtract, so you should get 6 raised to the power of minus 7. Yes. 6 raised to the power of minus 8 divided by 6 raised to the power of minus 10. This police officer is going to arrest somebody now. Okay, so what is the answer? Are we going to have 6 raised to the power of minus 18 or 6 raised to the power of minus 2? Okay, so if your answer is 6 to the power of 2, yep, you are correct. Right, so we move. Okay, we move. Law number 3. Indices in brackets. Example 1. Simplify 3 raised to the power of 5 brackets raised to the power of 3. 3 raised to the power of 5 in brackets, and then this now raised to the power of 3 again. So this means 3 raised to the power of 5 in 3 places. 3 raised to the power of 5 times 3 raised to the power of 5 multiplied by and the last 3 raised to the power of 5, if you want to express it that way. And if you also want to express it using the numbers, repeating the numbers, you are free. So let me just show you. So how many? 3, 5, 5, and 5. Can you see it now? So altogether, we should have 3 raised to the power of 15. Yes. So simplify a cube or a raised to the power of 3 in a cube square, a raised to the power of 3 in brackets, then raised to the power of 2 again. Indices in brackets, please take note of this. So the same method, a times a in 2 places again. And we should have a raised to the power of 6. Is there a quicker way of doing this? Yes, there is a quicker way of doing this. So in this case, you multiply the powers or the indices. That is 5 times 3. And that's why we get 3 raised to the power of 15. So if you have the same thing applicable to a raised to the power of 3 brackets raised to the power of 2, which means 3 times 2, and then we get a raised to the power of 6. So why do we have this here? No. This is A. Sorry for this. Okay. So you just multiply the powers. So when you have indices inside brackets, you multiply the two indices together. So just like what you can see. Now it is your turn to practice. Write as a single power of 4. Okay. So if your answer is 4 raised to the power of 15, absolutely correct. Good job. Write as a single power of 4, 4 raised to the power of 12 in brackets, then raised to the power of 3. So if your answer is 4 raised to the power of 36, you are correct. Yes. And then we have 4 raised to the power of minus 4 in brackets raised to the power of 5. So what are we going to have? So if your answer is 4 raised to the power of minus 20, you are correct. 4 raised to the power of 7 in brackets, then raised to the power of minus 2. Just multiply, keep multiplying the index. So you should have 4 raised to the power of minus 14. Okay. Multiply the power or the indices. 4 is to the power of minus 4 in brackets, then raised to the power of minus 7. So we multiply minus 4 times minus 7. So we should have minus 28. So the answer is going to be 4 is to the power of, sorry, did I say minus 28? No, because the minus we cancel minus. So minus times minus is plus. So we should have 28. Yes, I don't want to be arrested by this officer. Okay, so these are the laws of indices. Yes, these are the common laws, the major ones. So in my next video, I'm going to use different examples, complicated examples to show you how you can solve different problems in mathematics. Sorry, in indices. Not, of course, studying mathematics is meant for learning different topics in mathematics. But for now, we are considering indices. So this is where we are stopping today. I want to thank you especially for taking your time to watch this video. Please do like this video and subscribe to my channel for you to get notifications of my lessons. Thank you. If you have any questions, use the comment box and I'm going to respond to your questions. Goodbye.